Hello everyone, I hope you're doing well today. Today we're going to learn how to graph absolute value functions, which are functions in the form of f of x equals a times the absolute value of the quantity of x minus h plus k. To do this we need to follow 4 steps. Identify and draw the axis of symmetry, which is the line x equals h. Identify and plot the vertex, which is the point hk. Next, make a table of values, and then finally plot and connect the points from our table of values. You'll notice the steps here are very similar to that of graphing a quadratic function in vertex form. And x equals h is the axis of symmetry here, like in vertex form, as well as hk is our vertex, just like again graphing a quadratic function in vertex form. So this should seem very similar to what we've done in the past and very familiar to you. So let's look at an example. F of x equals the absolute value of the quantity of x minus 3 plus 2. Well, I can identify that 3 is in the position where my h is. So my axis of symmetry is the line x equals 3. Next, I can find my vertex. I already know that 3 is my value for h, and looking at my equation, 2 is the value for k. So the point 3, 2 is my vertex. Now when I make my table of values, I'm going to choose values of x to plug in that are both to the left and right of the vertex. So my vertex appears at the point 3, 2. So I'm also going to choose to plug in values of 2 and 1 and 4 and 5 for x. When I substitute in the value of 2 for x, I have the absolute value of the quantity of 2 minus 3. 2 minus 3 is negative 1. The absolute value of negative 1 is 1. Add 2 and I get 3. Then when I plug in 1, the absolute value of the quantity of 1 minus 3 is the absolute value of negative 2, which is 2, and 2 plus 2 gives me 4. Now since I have an axis of symmetry at x equals 3, I know that my table is also symmetrical, so I don't have to plug in 4 or 5. I know that if I plugged in 4, I would get a y value of 3, and if I plugged in 5, I would get a y value of 4. Now that I've created my table of values, I just need to plot my points and connect them to create the absolute value function. You should notice after plotting the points that our graph makes a V-shape. All absolute value functions will make a V-shaped graph. Please take a moment to pause this video and record the steps and this example in your notes. Now let's try looking at another example. Let's look at the function f of x equals negative 3 times the absolute value of the quantity of x plus 2 plus 8. Our steps are going to be to do exactly the same. First, I need to identify my axis of symmetry. In this case, my axis of symmetry is x equals negative 2. Remember, we're supposed to have x minus h inside the absolute value. Since I see x plus 2, I know that that is really x minus negative 2. So my value of h is negative 2. Now that I have my axis of symmetry, I'm going to identify my vertex. I know my value of h is negative 2, and my value of k is 8. So my vertex is the point negative 2, 8. Now I'm going to create my table of values, and I'm going to put my axis of symmetry directly in the center of the table. So I'm going to put negative 2 in the center. 2 points to the left of negative 2 are negative 3 and negative 4, and 2 points to the right of negative 2 are negative 1 and 0. I already know that if I plug in negative 2, I'll get an output of 8 because that's my vertex. Now if I plug in negative 1 into my function, I have the absolute value of negative 1 plus 2, which is 1. Absolute value of 1 is 1. Times negative 3 is negative 3, plus 8 is 5. Since my axis of symmetry is right here in the center, I know that my input -3 will also give me an output of 5. Now if I plug in 0, 0 plus 2 is 2, the absolute value of 2 is 2, times -3 is -6, plus 8 gives me 2. And again, because of the axis of symmetry, I know that my input value of -4 will also give me an output value of 2. Now that I've created my table of values, I can plot my points and connect them so that I create the graph of my function. Again, you should notice that the graph is a V-shaped graph, but this time our V is opening downwards, it is concave down. We could have known right directly from the beginning that our function was going to be concave down by looking at the value of A. If A is negative, the graph is concave down. If A is positive, the graph is concave up. So if you look back at our first example, our value of A was understood to be 1. Therefore, since our value 1 was positive, our graph opened upwards and was concave up. Please take a moment to pause this video, record this example in your notes, as well as any questions that you may have. Take care, be well, stay safe, and I'll see you shortly in our Zoom meeting.